Hi, welcome back to my class in Advanced Statistics. For today, we will take up the third and the last of the most commonly used probability distributions for discrete random variable. And it is the hypergeometric probability distribution. In binomial probability distribution, the population size or the number of elements in the population is large in relation to the sample size or the number of elements in the sample. And in that case, we can assume that the proportion of the population that represents success can be taken as the probability of success and can be held as constant from trial to trial. But in hypergeometric probability distribution, the number of elements in the population is small in relation to the sample size. And in this case, the probability of successes becomes dependent on the outcomes of the preceding trials, the trials that have taken place earlier. The probability of success in the next trial will depend on the probability of success of the trial that has already taken place. And in this case, the probability distribution of random variable is best described by hypergeometric probability distribution. And the probability of x representing the discrete random variable is given by the following formula. The probability of the discrete random variable x would take some value is denoted by p of x and is given by this formula for hypergeometric probability distribution. Combination of k taken x multiplied by combination of n minus k taken n minus x divide by combination of n taken n, small n. Capital N here is the population size or the number of elements in the population. Again, capital N represents the population size or the number of elements in the population, while small n represents the sample size or the number of elements in the sample. And in hypergeometric probability distribution, the population size is small in relation to the sample size. And K represents the number of elements in the population that are successes. Okay, here's the number of elements from capital N, the number of elements in the population that are successes. So this means that these k elements of the population possess one of the two properties, and this property is considered as a success. And small x represents the number of elements in the sample that are successes. The number of successes x in the sample is less than equal to k, the number of successes in the population, because k represents the number of elements in the population that are successes, and the sample is only part of the population, thus we expect the number of successes in the sample to be less than equal to k, the number of successes in the population. But k is greater than equal to k plus n minus n. We now take the first example for hypergeometric probability distribution. For our first example, consider the following problem. From a group of 20 PhD engineers, 10 are randomly selected for employment. What is the probability that the 10 selected include all the 5 best engineers in the group of 20? In this problem, the population size is 20. And from this population of 20 engineers, 10 are randomly selected for employment, which means that the sample size small n is 10. And we can see that the population size of 20 is small in relation to the sample size of 10. Thus, we employ the use of hypergeometric probability distribution. And from the population n of 20 engineers, 5 are considered as the best engineers. Therefore, 5 is equal to k. K is the number of successes in the population, or the number of elements in the population that are considered successes. And in this particular example, the success is referring to the best engineers. And among the 20 engineers, 5 are considered as best engineers. And we are asked the question, what is the probability that the 10 selected include all the 5 best engineers in the sample? Which means that in the 10 randomly selected engineers, the sample size of 10 includes all the 5 best engineers, and the number of elements in the sample that are considered successes is represented by x. And in this particular example, x is equal to 5. That means all the 5 are included in, all the 5 best engineers are included in the sample of 10 randomly selected engineers from 20 engineers. And we want to find the probability that x is equal to 5. We want to find the probability that x equals 5. That means all the 5 best engineers are included in the sample of 10 randomly selected engineers from the population of 20 engineers. And we apply the probability, the hypergeometric probability distribution. probability of x by hypergeometric probability distribution is given by combination of k taken x multiplied by combination of n minus k taken n minus x over combination of capital N taken small n at a time. We substitute k is 5, x is 5, capital N is 20, k is 5, small n is 10, x is 5, capital N is 20, taken 10 at a time. And combination of 5 taken 5 using your calculator is equal to 1. And this simplifies to combination of 15. 20 minus 5 is 15. Taken 10 minus 5 is 5. Over combination of 20 taken 10 at a time using our calculator, we compute the combination of 20 taken 10. And you should get 184,756. We also compute the combination of 15 taken 5 using our calculator. And you should get 3,003. And we divide 3,003 by 184,756, and we round up the answer in the calculator to 2 decimal places, or to 4 decimal places, and multiply it by 100%, and you round it off to 2 decimal places. 3,003 divided by 184,756, and the answer in your calculator, multiply that by 100, and you round it off to 2 decimal places, you should get 1.63%. Hence, if you have 20 engineers that are all qualified, but 5 of them are considered as best engineers, and you will select 10 engineers at random from 20, the probability that all the 5 best engineers will be included in the sample of 10, randomly selected from 20 engineers, is 1.63%. For our next example, consider the following problem. A particular industrial product is shipped in lots of 20. That means each shipment of the industrial product contains 20 items. A sampling plan requires sampling 5 items from each lot and rejecting the lot if more than one defective is observed. So there is a lot of 20 items to be shipped, but before this shipment is made, the items are tested for quality control. And if more than one defective is found among the 20 items in the lot, then the lot is rejected. If rejected, each item in the lot is then tested. If a lot contains four defective items, what is the probability that it will be accepted? In this example, our population size is 20. And among these 20, a sample of 5 items are selected because that is the sampling plan of the manufacturing company. And again, the population size of 20 is considered small in relation to the sample size of 5. And in this particular problem, a success is referring to the defective item. If an item is found defective, then it is considered a success. And in a lot of 20 items for shipment, 4 are found to be defective, and we take 4 as K. And the discrete random variable x is the number of successes in the sample. That is the number of defective items in the sample of 5 items selected from 20 items in the lot. And in this problem, we are asked what is the probability that the lot will be accepted. The lot will be rejected if more than one defective is found, tested. If more than one item is tested defective in the sample of 5 items selected from 20 items in the lot. So this means if more than one defective is tested among the sample of 5 and the lot is rejected, that means that the lot will be accepted if the number of defective item is not more than 1, which means that it can be 1 or 2. It can be 1 or 0. The lot will be accepted if in the sample of 5 items selected from 20 items in the lot, the number of defective items tested is either 1 or 0. Then the lot will be accepted, because the problem says that the lot will be rejected if the number of items in the sample of 5 that is tested defective is more than 1. That means from 2, 3, 4, 5, the lot will be rejected. And that means the lot will be accepted if the number of items that is tested defective in the sample of 5 is 1 or 0. Again, in this problem, we are asked to find the probability that x is 0. There is no defective item in the sample of 5 items selected from 20 items in the lot. Or x is 1, 1. There is one defective item in the sample of 5 selected from the 20 items in the lot. And in this case, the lot will be accepted because the problem says that the lot will be rejected if more than one item is found defective in the sample of 5 items selected from 20 items in the lot. And because the sample size is small, we use the hypergeometric probability distribution, where the probability of the discrete random variable x is given by this formula, where k is 4. We are given 4 defective items in the lot, and x here is 0 and 1, and small n, the sample, is 5. The probability that x equals 0 or x equals 1 by addition property of probability is equal to probability of x is 0 plus the probability of x is 1. For the probability that x is 0, there is no defective item in the sample of 5 items. We apply this formula. K is 4. Combination of 4 taken x 0. Multiply by combination of capital N. The population is 20 items in the lot. Minus k, the number of defective items in the lot is 4. Taken 5 minus 0. Over combination of 20 taken 5 at a time. Plus the probability of x is 1 is equal to combination of 4, k is 4, taken x is 1. Multiply by combination of 20 minus 4, taken 5 minus 1. Over combination of 20 taken, this should be small n. But we have the right value here. Combination of the population size taken the sample size. Combination of 20 taken 5 at a time. Divide by combination of 20 taken 5 at a time. And we compute the value of each of these in the sum using our calculator. We now compute the value of each of these. Combination of 4 taken 0 is 1. And you can check that using your calculator. And this simplifies to combination of 16, 20 minus 4 is 16. Taken 5 at a time. 5 minus 0 is 5. Hence, the numerator of the first term is combination of 16 taken 5. Divide by combination of 20 taken 5. We compute that using our calculator. And you should get 15,504. The second term, we compute combination of 4 taken 1 using our calculator, and that should give you 4. 4 multiplied by combination of 20 minus 4 is 16, taken 5 minus 1 is 4. So this simplifies to combination of 16 taken 4. And the denominator is the same as the denominator of the first term. Combination of 20 taken 5 is 15,504. We compute combination of 16 taken 5 using our calculator. And you should get 4,368. Divide by 15,504. We compute combination of 16 taken 4 and multiply that by 4. Using our calculator, and you should get 1,820. That's combination of 16 taken 4, multiply that by 4. You should get 7,280. And we have the common denominator of 15,504. So we can add the numerator 4,368 plus 7,280. 7,280 plus 4,368. And you should get 11,648. Divide by the common denominator 15,504. Now we divide 11,648 by 15,504. 11,648 divided by 15,504. And the answer in your calculator, multiply that by 100%. And then you round it off, the answer in your calculator, to 2 decimal places, and you should get 75.13%. Thus, if there is a lot of 20 items for shipment, and before shipment you take 5 items at random from 20, and you test these 5 items, the sample of 5 items, and none or one of the 5 items is tested defective, then the lot of 20 items will be approved for shipment. And the probability that the lot of 20 items will be approved for shipment or will be accepted, because among the 5 items in the sample, only one or none of the 5 items tested defective, is 75.13%. This is the probability that the lot of 20 items will be accepted, approved for shipment. because either one item is tested defective in the sample of 5 items selected from 20 items in the lot, or none of the 5 items in the sample tested defective, and so the lot of 20 items will be accepted and approved for shipment. For your practice, please try the following exercise. 1. Let x be the number of successes observed in a sample of n, small n, equals 5 items, selected from capital N equals 10. Suppose that of the capital N equals 10 items, 6 are considered successes. Find the probability of observing. Letter A, no successes. Letter B, at least 2 successes. And C, exactly 2 successes. In exercise number 1, the population size is 10, capital N is 10. And the sample size, small n, is 5. And of the population size of the 10 elements in the population, 6 are considered successes. Number 2, a company has vacancies for 2 positions of vice president. The vacancies are to be filled by randomly selecting 2 people from a list of 5 candidates, with 2 women and 3 men, all of whom have worked for the company for a long time. What is the probability that at least one of the women will be selected, and B, neither or neither woman will be selected? And that completes our lesson on probability distribution for discrete random variables. In the next lesson, we will start up with probability distributions for continuous random variables. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and leisure. Thank you for joining me in my class today in Advanced Statistics.